Hi, and welcome back to the channel. This week's problem is about finding the area of this blue triangle. It's got an angle of 60 degrees in it. We've got an area of the pink triangle as being 24. We've got an equilateral triangle, EFG. We've got an isosceles triangle, EDG. And we have got a few other triangles in there as well, joining up with either the vertex of the square on the outside or the midpoint of the sides of the square, apart from point H. So just be aware of that. Now, can you solve this problem yourself? If you think you can or you want to have a go, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do with this problem was to label the sides, and I gave them a length of 2x. Now, the reason I did that is so that the, half the length of one of the sides would therefore be x and not x over 2, which makes it a little bit nicer. So I therefore labelled half the side length as x. Now from there, I labelled my 60 degrees in my equilateral triangle. And that meant, well, actually regardless of that, but I could also label the 45 degrees in the isosceles triangle bottom left. From there, I've labelled this angle, as you can see here, as theta. Now, I don't know what that is at the moment, but I could work that out because I've got the proportion or the ratio of 2x to x, and I can use my right angle trigonometry. But I'm actually going to leave that for the moment. And I can work out this angle that I've just marked on the diagram there as 75 minus theta, because we know that angles on a straight line have to add up to 180 degrees. I've then worked out this hypotenuse here by doing x squared plus 2x all squared and square rooted, and that gives an answer of x root 5. So let's put that on the diagram. I can also work out the length of the sides of the equilateral triangle by Pythagoras again. So x squared add x squared and square root it is x root 2. And that is going to be the same, obviously, for all the sides of that equilateral triangle. So let's put those on the diagram. Now, next, I know that this angle here is 15 degrees. And the reason why that is important is so that I can work out this length of our blue triangle. When I've got that length, I can use half AB sine C to work out the area of the blue triangle, obviously once I've got x. So I'm going to work out that side of the blue triangle by using trigonometry. Cos 15 is adjacent over hypotenuse. Now, the adjacent is x, so let's replace that, and then let's do some rearranging to get that the hypotenuse is x over cos 15. Let's put that on the diagram there. Now I want to work out x, and actually I can use the pink triangle to work out x. We know it's got an area of 24, and again I can use a half AB sine C. That gives this, a half x root 2 times x root 5 times sine 75 minus theta is equal to 24. Now I can then expand those first two brackets to give x squared root 10. And then I want to consider this sine 75 minus theta. We know that sine x is equal to cos 90 minus x. So using that, I can do cos of 90 minus, in brackets, 75 minus theta. And what I get is cos 15 plus theta. Okay. Now from there, what I can do is I can use the not double angle formula, maybe that's not the right terminology, but cos A plus B, and I can get this, cos 15 cos theta minus sine 15 sine theta. I can simplify that, or at least the first bit, that cos 15 to root 6 plus root 2 over 4, and then the cos theta, actually I get from this right-hand side right angle triangle. Okay, so what I'm doing there is, well, cos theta is adjacent over hypotenuse, so I'm doing x over the hypotenuse, which is x root 5. I'm then going to replace the sine 15, or simplify that first, sorry. Then I'm going to replace the sine 15 with root 6 minus root 2 over 4. And then I'm going to substitute in for sine theta. Now, sine theta, again, using that right-hand, right-angled triangle, sine is opposite over hypotenuse, so it's going to be 2x over the x root 5. Cancelling the x's out or simplifying that leaves us with 2 over root 5. From there, I'm going to multiply the fractions together. Gives us this. So 4 root 5 is the denominator for both, and then I can collect the terms on the top, the numerators of those fractions. Okay, and that gives us 3 root 2 minus root 6 over 4 root 5. Now I'm then going to substitute that back in to the equation I had for the area of that pink triangle. Okay, this was the equation. Substitute it in, we get this. We've got everything we need there now to work out the x, so it's just a case of rearranging. Okay, so double both sides. I'm then going to put the root 10 inside of that bracket. I'm going to simplify those thirds. I'm going to simplify the fraction. I'm going to simplify it a little bit more. And then I'm going to divide the 48 by that. I'm going to rationalize the denominator at this point, and that is going to give us 48 plus 16 root 3. Now I'm going to save that for later because actually what we need is x squared, not x. So I don't need to worry about working the x out. Now looking at the blue triangle now, a half AB sine C, again, using that sine 60. Okay. What I'm going to do is I'm going to multiply, replace the sine 60 first of all with root 3 over 2. Then I am going to, as you can see, multiply the two fractions together. I'm going to bring in the bracket with the x in, so the x root 2, make that x squared root 2 as the numerator. And then from there, I'm going to replace the cos 15 with root 6 plus root 2 over 4. I'm then going to times top and bottom of this fraction by 4 to cancel out the denominator in the denominator. And then at this point, it's a little bit messy. Actually, I want the x squared to come out so that I can replace it with the 48 plus 16 root 3 that we found earlier. So I'm going to do that. I'm going to bring the other fraction inside the bracket. I'm going to get this root 6 over root 6 plus root 2. Now I'm going to replace the x squared with 48 plus 16 root 3. And actually, I'm going to bring that into that bracket. And we're going to get 48 root 6 plus 16 root 18 over root 6 plus root 2. I'm going to simplify the root 18. So we've got 48 root 6 plus 48 root 2 over root 6 plus root 2. Take that 48 outside the bracket, and now inside the bracket, we've got the same on the top as on the bottom. So that's going to have a value of 1, which gives us a final answer for the area of the blue triangle as 48 units squared. If you were able to solve this problem yourself and you use a different method or the same method, put it down in the comments below. It's always good to read your different solutions and to share with other people. And all that is left to say from me is thank you so much for watching. If you enjoyed this video, drop a like on the video. And if you're not already, please consider subscribing so that we can keep on gaining subscribers and getting over that 1,100 mark that we're hovering at the moment. Thank you so much, and I'll see you next Monday, 5 PM for another problem-solving video. Until then, bye-bye.